Hi guys, this lesson is on inscribed angles. Okay, now remember we had this concept of inscribing something inside of a circle before. So when you have a circle, let's say, and you inscribe a rectangle, right, all the points have to actually touch on the circle. Okay, that would be inscribed. The same thing is going to happen when we inscribe just an angle. Instead of an entire rectangle, we're just going to inscribe an angle. So if I inscribe an angle, all the points have to actually touch on the circle. All right, so today we're going to really talk about inscribed angles. So an inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. So again, there's that vertex, and the sides of that angle are going to be chords. All right, an intercepted arc, this is the intercepted arc right here. This is the intercepted arc. This is the arc that is basically cut off by that angle. So an intercepted arc consists of endpoints that lie on the sides. Okay, there's an endpoint there and there's an endpoint there, and they lie on the sides of an inscribed angle, and then all the points in between them. Okay, so that's what when we talk about an intercepted arc, we're talking about an arc that's cut off by an angle there. Now, a chord or an arc subtends an angle if its endpoints lie on the sides of the angle. So basically, that word subtends is kind of a weird word. Basically, what it's saying there is that if you have the endpoints of an arc or a chord, and they lie right on the sides of the angle, right? That's what that word subtend means. Okay? All right, so let's take a look at the inscribed angles here. All right, angle DEF is inscribed. Notice its points all touch on the circle. Its vertex is on the circle, and these 2 points, which are on that arc, they are also on the sides of that angle. Arc DF, that is the intercepted arc. Arc DF, that's cut off by the angle. And we say that DF subtends angle DEF because those 2 points are actually on that angle DEF. Okay, again, subtends just means it's on the sides of that angle there. Those 2 points are on the sides. Okay, now let's talk about the inscribed angle theorem. Basically what this says is if you have an inscribed angle, and there can be 3 different scenarios. In other words, the angle can go through the center of the circle, the center of the circle can be inside the angle, or the center of the circle doesn't have to be in the angle at all. Okay? Any of these 3 cases, you're looking at an intercepted arc there, and you're looking at an inscribed angle. So in all 3 cases, we have intercepted arcs and we have inscribed angles. And what this theorem basically says is this angle here is going to be half of the measure of the intercepted arc. It's going to be half. So, for example, if this arc here was 80, that angle would be 40. If this arc over here was 100, this angle over here would be 50. If this arc here was, say, 30, that angle inside there would be 15. So the measure of the angle is equal to half of the arc. And the opposite is true too. If you know the measure of the angle, then you can double it to get the arc. So the measure of the arc would equal 2 times whatever the measure of the angle is, right? So 2 times 40 would be 80. 2 times 50 would be 100. 2 times 15 would be 30. All right, let's apply that to some of these problems here. We're going to find the measure of angle LMP. So that's this angle right here, LMP. And that angle goes with this arc right here. So you notice it stops at L, it stops at M, and it goes, P, and it goes across. Stops at L and P and goes across. That angle is related to this arc right here, but they're not equal. The only time that it is equal is when it comes from the center of the circle, right? We had that. There is the concept of the central angle that actually comes out from the center. That is where it's the same, right? So if this angle was 40 degrees, this arc would be 40. That's when it's a central angle, okay? This over here is an inscribed angle. So that's the difference. And again, in this case, it would be half. So if this was 40, that would be 80. They would be half as opposed to equal to each other. So this is central angles. They are the same. Inscribed angles are half. So down in this problem down here, we have 36. We have to cut that in half. So half of 36 would be 18. So the measure of that angle there would be 18 degrees. Okay, now they're asking us to find the measure of arc MN. That arc MN stops at M and N. You go across to find the angle there. That angle is 48, so we have to take it times 2. Remember, the angle is always smaller than the arc. So we're going to double that 48. 48 times 2 would be 96. So that arc there would be 96 degrees. All right, let's look at the next one. We have to find the measure of angle GFJ, this angle right here. Now it stops at G, it stops at J. So that arc there is going to have a relationship with that angle. It's going to be half of the arc is going to give us the angle. So half of 110 would be 55. So that angle there would be 55 degrees. Then we have to find the measure of arc FH. That's this right here. So again, it stops at F, stops at H. Follow across where the angle goes. The angle goes to that 36 right there. The angle is smaller than the arc. So we have to take the 36 and we have to multiply that 36 times 2 to get 72 for that. So that arc there would be 72 degrees. Okay, let's look at the next one down the bottom. We have to find the measure of arc A to D to C. That's a big arc there. A to D to C. We need to find all of that. All right, let's talk about how we're going to do that. That one gets to be a little trickier. Now, notice that it is stopping here at A and stopping here at E. Now look for an angle that goes with it. Do you see how this angle goes across? There's an angle right in here. It's very hard to see, but it goes from B to A, which was one of the endpoints, and C is the other one. It's from B to C. There's an angle right there that's 135. That angle goes with that arc. That angle of 135, we have to take that 135 times 2 to get the measure of that arc, and that arc is 270 degrees there. That's that entire arc coming off of that angle. We also have to find the measure of angle DAE. Now DAE goes with this arc right here. The arc is 76. Remember, the arc is always bigger than the angle. So we have to take that 76 and divide it by 2 to come up there with 38 for that angle measure. Okay, let's look at the next one. Angle RST. So that's R to S to T. Now again, look where it goes. This is the angle we have to find. It stops at R, stops at T. There's an arc there associated with that. That arc is 120. So to find that angle, we're going to cut it in half. The angle is always smaller than the arc. So we get 60 for that angle right in there. And next we have to find arc SU. Again, starts at S, goes to U. So see where it goes across, and it goes across over here. That angle's 40. All right, the angle is always smaller than the arc. We have to take the angle times 2 to get the arc. So 40 times 2 there would equal our angle of 80. Okay? All right, let's go on to the next concept. All right, this concept can be a little tricky. What you're seeing in this picture is you're seeing 3 different angles, but here's what you have to notice about all 3 of these angles. The blue angle, angle ACB, starts at A, goes to C, comes back to B. So it's off of that arc AB. The red angle, ADB, again, starts at A, goes to D, and comes back to B, is that same angle. And angle AEB starts at A, ends at B also. All 3 of those angles go with that arc. So all 3 of those angles there are half of whatever that arc is. So if that arc right there was 100 degrees, all of these angles in here would be 50 because they all intercept the exact same arc. If inscribed angles of a circle intercept the same arc or are subtended by the same quarter arc, then the angles are congruent. So if they intercept the same arc, the angles here are all congruent. All 3 angles intercept the same arc, so therefore they are all equal to each other. Okay? Now, the next concept talks about an angle inscribed in a semicircle. So whenever you have an angle, an inscribed angle that is subtends, which means, again, the endpoints there are on the sides of that angle where it starts and stops. And if you notice, that line right there is the diameter. It's going right through the center of the circle. So it's stopping here at one endpoint of the diameter and the other endpoint. Those 2 points are on that angle. It starts, it goes across, hits another point, and it comes back. Remember, this angle right here, all of this is 180. So if you think about it, that angle would have to be half of the 180. It's going to be a right angle. An angle inscribed, starting, going across, stopping, and then coming back. An angle inscribed in a semicircle is always going to be a right angle. So when you have an angle in half of a circle, it's always going to be a 90-degree angle. Okay, let's take a look at those two concepts. In this concept right here, again, here we see an angle inside of a half of a circle. It's inscribed in half of a circle. So that means that that angle right there has to be 90. So 5x plus 8 has to equal 90 degrees there. Okay, so we have to solve for x. So we're going to subtract 8 on both sides. We get 82, and x works out to be 16.4. That's our value of our x. All right. Number 7 underneath of it is the exact same kind of question. Again, we have an angle inscribed in a semicircle. So that means that has to be 90 right there. We know that has to be 90, so that 8z minus 6 has to equal 90. Add 6 to the other side, we get 8z equals 96, and our z there works out to be 12. Okay, that's that little angle right in there. That angle there we know is 90, so the z works out to be 12 there. All right, over here we have that angle, that concept where the two angles are intercepting the same arc. Take a look. This angle right here goes to this arc FH, right? But this angle right here, which is FGH, that angle also goes to the same arc. So both of them go to the exact same arc. See where they go? One goes to here, that arc, and the other one goes to here. And again, if you looked at these two angles that we have in this picture, we have angle FJH and we have angle FGH, right? And if you notice, they start and stop at the same letters there, okay? So they're intercepting that same arc. Those two angles, because they touch the same arc, are going to be congruent. So that 5Z is going to equal the 4z plus 9. They're going to be equal to each other. And then we can subtract the 4z, and we get z equal to 9 there. And then, of course, you had to plug it back in to find the measure of angle FJH. So that's going to be 5 times 9 there, which would be 45. And again, both angles would be the same, so we could do the same thing over here, right? 4 times 9 is 36, plus 9 is, again, 45. Okay? This concept is, again, identical. You have two angles that are touching the same arc. You have angle EDF and you have angle EGF. And notice they both start and end at E and F. So those two angles are off of the exact same arc EF, which means they're equal. So we set them equal to each other and we solve for x. We're going to bring the 2x over this way. We get 4x. Subtract 3. Let's see, am I subtracting 3? I need to, subtract 3. So I have this wrong here. So this is actually 72. And let me just double check my math there since I did not set that up correctly. We've got 72 divided by 4, and I get 18. So my answer is right. I just had the wrong number. I added instead of subtracted. So we have to make sure we subtract that 3 over there. Okay, so x is 18, and then when you plug it back in, you have the measure of angle EDF, which is this one. So that's 2 times 18 plus 3. So that's 36 plus 3. We get 39 for that angle measure there. Okay? All right, one final concept in this lesson, and this has to do with whenever you have a quadrilateral, any quadrilateral, it can be a rectangle, a rhombus, a square, a trapezoid, anything you want, any quadrilateral that you put inside of a circle, inscribed in the circle, again, where if you looked at this figure, all 4 of those points actually touch on the circle. The opposite angles will end up being supplementary. Okay, opposite angles will end up being supplementary. So if a quadrilateral is inscribed in a circle, the opposite angles are supplementary. And again, this doesn't matter for what shape it is. The opposite angles will add to 180 there. So angles A and C add to 180, and angle B and D also add to 180 there. All right, let's apply that concept. Okay, here we go. So let's take a look at this first problem. We know we have a quadrilateral. All the opposite angles there have to add to 180. Now, I don't have anything over here at V, so I can't add these two together, but I can add these two. We know that the measure of angle R plus the measure of angle T will equal 180 degrees there. So 7y plus 11y is going to equal our 180 there. So we get 18y is equal to 180. Divide by the 18, y works out to be 10. Okay, so that's your y value. And now we're going to plug everything back in to find the measure of each angle. So the measure of angle R is equal to 7 times 10, right, which works out to be 70. And the measure of angle S is our 8y plus 8. So 8 times 10 plus 8 there would be 80 plus 8, which is 88. Okay. And the measure of angle T there would equal 11 times 10. So that is 110. Now that leaves angle V. So how are we going to find angle V? Well, remember something here. The S and the V, the measure of angle S plus the measure of angle V equals 180 there. So if I know what S is, I know S is 88. And I don't know what this one is, but I'm able, for the measure of angle V, I'm able to take 180 minus the 88, and that will give me the measure of angle V, which works out to be 92. Okay, so we can still find that. We have to find S first. Once you find S, you take 180 minus whatever S is to get V. Okay? All right, let's look at 11. We'll do another one of these, and then we'll go over these two examples, because these two examples these are all the same. Okay, so let's look at this one. Again, we've got a quadrilateral inscribed. All 4 of these points actually touch on the circle, so the opposite angles there are supplementary. So the measure of angle J plus the measure of angle L is equal to 180. I would do K and M, right, but I don't have anything at M yet. So I can't really add those together to equal 180, so I'm going to have to wait on that one. All right, so for J, we have 2Z plus 2. For L, we have Z minus 17, and that all equals 180. So I have 3 Z's, and I'm going to combine like terms here. Minus 15 equals 180. 3Z is equal to 195, and Z works out to be 65 there. Now I need to go back and plug everything in. So for the measure of angle J, I have 2 times 65 plus 2. So that's 130 plus 2. That's 132. So angle J is 132. All right, for the measure of angle K, that is going to be 65 plus 25, right? That's the Z plus 25. So we end up with 90 for that one. That's 90 degrees. For the measure of angle L, we're going to plug that in. We get 65 minus 17, so we get 48 for that one. And then finally, there's the measure of angle M. We have to know K in order to find M. The opposite angles there will be supplementary. So the measure of angle K plus the measure of angle M equals 180. I know what K is. I know K is 90. I don't know the measure of angle M, but if I take that 180 minus 90, I will get 90 for that answer there. Okay, so that's how you find all those. And these two problems are the exact same thing, right? Opposite angles are supplementary. These are the two I have first. So I add those together to set them equal to 180. Right, there it is. I end up with my x equaling 12. And then I plug the 12 back in for all the angles. And when you get down to finding the angle D, you have to take your B and D add to 180. So whatever angle B was, that angle B there worked out to be 75. We have to take 180 minus 75 there to get this angle to be 105. Okay? This question number 12 works the exact same way. Okay, I don't have Q right now, so I can't add those to equal 180, but I do have M and P. So M and P add to 180. We've got the 4x plus 5 plus the 3x plus 17 equals 180. Simplify, combine like terms. We end up with our x equaling 24. We plug it back in for M, for N, and for P. We get all 3 of those angles, but to find Q, don't forget, Q and N there are going to add to 180. So I have to find N first. I found N. N was 86. Q and N add to 180. So I simply have to just simply take, to find Q, don't know that. I have to subtract there the 180 minus the 86 to get that 94 there. Okay, to get that 94 right there, just subtract. And then we find all those angles. Okay, let's look at the bottom part here. We've got another one of these. We have to find the measure of angle BCD. B to C to D. All right, well, this goes back to that inscribed angle concept. We have an angle right there. Remember, the angle is always smaller than the arc. Cut the arc in half, and we will find the angle. So we have to take that 62 divided by 2, and we get 31 for that angle in there. All right, the next thing we had to find was arc AC. Arc AC goes to A and C. So we go from A all the way over to B and come back. That angle of 30 is going to be related to that arc AC there. Remember, the angle is always smaller, so 2 times the angle, 2 times the 30 will equal that arc of 60 there. Okay? And over here we had one more final question there with the quadrilateral inscribed inside of the circle. Again, the opposite angles are supplementary. You have 2 options. You can do these two first. The 2x plus 4 plus the x minus 4 equals 180. And when you do that, the 4's cancel out, and you're left with 3x equals 180, x equals 60. Or you actually have something in both of these two corners. So those two will add to 180 also. X plus 2x equals 180. Once again, you have the same thing. 3x equals 180, x equals 60. And the x should work out to be the same. So it doesn't matter which way you do it to get that x value. Then you just take it and plug it back in for each one of those to come up with your answers here. Right? You're just plugging the 60 degrees back in for your x in every one of these vertex points to get your angles. Okay? All right, guys, if there's any part of this lesson that was confusing for you, please just go back and rewatch. Good luck.